This is R.D. Sharma solution, class 12th, chapter 17. We are taking MCQ, increasing and decreasing functions, multiple choice questions. The interval of increase of the function fx is equal to x minus e raised x plus 10 pi 2 pi by 7 is. Now in this interval, we have to find out the increment, the interval in which it is increasing. So f dash x has to be greater than 0. That is the only thing which we need to prove. And the f dash x, which is the differentiation, x is 1, e raised x is e raised x. And this is a constant. This is for just to confuse the candidate, student, that is tan 2 pi by 7. That is just a constant. And when we differentiate it, it is going to be 0. So we have dash x equals to 1 minus e raised x greater than 0. That means 1 minus ex is greater than 0, 1 is greater than e raised x. Or you can say e raised x is less than 1. Now the next thing, what comes here is, e is what? You know about e. E is a constant value, 2.1744 something. Now constant value, if you put any value x over it, that is, it has to come lower than 1. I am saying 2.17 is there. Now if you put any positive power, 1, 2, 90, 90 lakh or whichever, it will be greater than 1. But if you put 2.17 to the power, anything which makes it lower than 1. So this is possible when we have less than 0. That is, if you put negative 1 by 2.174, that is going to give you a value which is less than 1. So this minus 1, this is basically x should be less than 0. In number line, if I want to show it, anything which is less than 0, you will go up to negative infinity. So negative infinity and 0, that is the interval they are asking, is from negative infinity to 0. X belongs to negative infinity to 0. What is the option? This is the second option we are talking about. Now let us see how you are going to write it, because writing is very important. It's a very straightforward question. The function fx is equal to cot inverse x plus x increases in the interval. In which interval it is increasing? First thing is f dash x greater than 0. That is what we do normally. If it is decreasing, we just make it as less than 0. The differentiation is cot inverse x is minus 1 by 1 plus x square. That is the differentiation. X is 1. This is 1. Now let us take the LCM to make it more simplified. Multiply cross, write it, and multiply the denominators and just write it in the denominator. 1 gets cancelled. You have x square by 1 plus x square. This I hope you'll be able to do by yourself also. Now this has to be greater than or equal to 0 because it is increasing. Now you tell me, x square. Just use a simple logic. X square will always be positive. Even if you add 1 with it or any number which is positive, it is going to be positive only. That means this whole value, numerator, denominator involved or collectively said, this will always be greater than or equal to 0. So if you put any value negative or positive, you are going to get always positive. It is always greater than or equal to 0. Because negative value will be negative infinity to 0. You can put any value, but when it is squared, it will always be positive, because anything even powered to any x value or y value, it will always be a positive value, right? So this is asking about the function. This is in the interval. Which interval it is increasing? In which interval? So you can say x belongs to, that is, you are going from negative infinity to infinity. I'm saying it will always be positive, but negative infinity to infinity the answer. So this is the simple explanation. It's very simple if you show it on the number line. The function fx equals to x raised x decreases on the interval. Now we have to show the decrement. Well, first thing first come here is the differentiation, and I hope you are well aware of the differentiation we have done in the actual differentiation when we did it. So x raised x can be done by using the log. That is, if I write fx equals to x raised x, then the differentiation will be what? You have to take log on both the sides, then the differentiation will start. So when you take log fx, this is log fx, and you have log x raised x. So this x is going to come forward. X will come in front of log, and internal x will remain like that. So x, the base is not given. We have taken the base as e. Let us differentiate it now, because differentiation of log anything will be 1 by that thing. That is, when we do a log fx differentiation, it will be 1 by fx. I'm differentiating both the sides. So it is going to be 1 by fx. Now the differentiation of fx is going to be f dash x. Log, whatever it is there, it will be 1 by that thing, and then differentiation of that thing. How about x log x? X log x is 1 by x, plus this is log x. Differentiation of x is going to be 1. This gets cancelled. You have 1 plus log x, and on the left you have f dash x, and this fx goes on the right side. I've just cross multiplied. You already know it. X raised x we have started. Fx you can just replace it by x raised x. into 1 plus log x. This is your differentiation. Now this has to decrease. Decrease means this whole content should be less than, or this whole expression should be less than 0. That is x raised x 1 plus log x less than 0. Now there are two terms here. First is, when you have log, there can be nothing negative inside. X should always be positive because log is defined for the positive values. X should be greater than 0. Now when x is greater than 0, anything of the same power, if 2 is, I'll just give an example. If 2 is greater than 0, 2 raised 2 will also be greater than 0. That is 4 will be greater than 0. That is what? X is any number, and any number raised to that number only is going to be greater than 0 when that number is greater than 0. So the first term is greater than 0, that is positive. Now in order to make this both term multiplied less than 0, the second term has to be negative. That is the whole logic. That is 1 plus log x should be negative. It should be less than 0. Let us take 1 on the right hand side. Log x should be less than negative 1. That is e power, the power is e, that is the base is e. When we say log base a, b, c is equal to, it's simply a raised power c is b. So e raised a negative 1, this is x will remain here and this will go on the right. E raised minus 1, x should be less than e raised minus 1. Same logic of log I have just written like this. Just forget about less than sign, keep it equal and then just replace it by less than. Then you will be able to write it properly. So x is less than 1 by e. E is a constant value, 2.714 something. So it will be positive only. 1 divided by 2.714 will be point something, 0 point something. If you even put e raised minus 1, if e is greater than 1, e is greater than 1 means 2.714 is already greater than 1. Okay. So x should be less than e raised minus 1. This I started. And I told you x is less than 1 by e because e raised minus 1 is 1 by e. Two things we found. X should be less than 1 by e, and second thing we got from here is x should be greater than 0. I hope you got the idea. The first term, it has to be positive, greater than 0. X has to be greater than 0. The second one is x should be less than 1 by e. Now combine these both and just join them. That is, x should be greater than 0 and this is 1 by e, x should be less than 1 by e. So this is the common point, this is the intersection point, and that is going to give you the interval. So x should be between 0 and 1 by e. Then you will say, okay, this is going to decrease. The third option is the correct option here. Now let us find out how we are going to actually do it. This is the different steps which you are going to follow, and I will encourage you to write or make the diagram that will effectively prove your point to the examiner. The function fx is equal to 2 log x minus 2 minus x square plus 4x plus 1 increases on the interval. First thing is we have to differentiate it, and increases in the interval means it has to be greater than 0. Whenever we have log, sine, cos, the domain you have to find out by yourself. I am saying whenever you have log and you have any term inside, say x, this x should be greater than 0. It should not be equal to 0, it should be greater than 0. When you have this x minus 2 inside, the same logic goes for that thing also. That is, x minus 2 should be greater than 0. That is the logic we know about log. So x should be greater than 2. One thing is x has to be greater than 2. Below 2, this whole expression becomes invalid, or you are not able to solve it right now. The logical value is greater than 2. So domain becomes 2 to infinite because x cannot be less than 2. 2 to infinite, it can be any value. Now coming to 2 log x minus 2 minus x square plus 4x plus 1. So f dash x is, let us differentiate 2 log x is 1 by x minus 2. Differentiation of x minus 2 is going to be 1. And minus 2x, 4x is 4 plus 1 is 0. Now we are going to solve it, and I hope you will be able to solve this properly, because just take the LCM and there will be an expression. And let me write the final version because I hope you will be able to do it. It's very straightforward. So final version is going to be minus 2 x square minus 4x plus 3 divided by x minus 2. That is going to come. Okay, it is increasing, so it has to be greater than 0. F dash x or differentiation should be greater than 0. Now tell me, minus 2, it is less than 0, no problem at all. X minus 2, I already told you that it has to be greater than 0. So x minus 2 is greater than 0. So that 3 terms on the left, minus 2 is less than 0, x minus 2 is greater than 0. So this cannot be negative. This is negative. I am saying x minus 2 is positive. X square minus 4x plus 3, because minus and x minus 2 is again positive and minus 2 is negative. This is positive. Okay, I've just changed it because I wrote negative first. So the below x minus 2 is greater than 0, it is positive. Minus 2 is negative. So what should x square minus 4x plus 3 sign should be? I am saying we have 3 terms a, b, c. A is negative, C is positive. What should be B so that the whole multiplication and division becomes greater than 0. It has to be negative because negative is positive. Okay, so you need a negative value. That's what discussion is all about. So we have x square minus 4x plus 3 should be less than 0. It should be negative. Next step comes is we have the x square minus 4x plus 3 and it has to be less than 0. Let us now take the roots. X square minus x minus 3x plus 3 equals to 0. Now we'll not make it as 0. We'll just find out the factors. X into x minus 3 you can take common x minus 1. Factor will be x minus 1 into x minus 3. That is, this is going to be 0 at x equals to 1. This is going to be 0 at x equals to 3. So we have, now let us use the number line. It will be better to have the number line. To get it less than 0, I already told you in the beginning of the chapter, I explained you properly that when factor multiplied is less than 0 or factor multiplied is greater than 0, what is the final result? So we can get the final result, that is 2 to infinite. The first one came, I told you already. That was the domain, log x minus 2, I told you. And here the answer is coming between 1 and 3. But domain is saying that it has to be greater than 2. So what is the common point here? The common point is between 2 and 3. So x should belong to 2, 3. And that is the interval in which the whole thing will be increasing. So this is the stepwise discussion of what I just told, and whenever you have log, you have to find out the domain by yourself so that you know that how it's going to be finally working. If the function fx equals to 2x square minus kx plus 5 is increasing in 1, 2, then k lies in which interval? It is increasing. Okay, so clearly it is being shown that it is increasing. So what we'll do, we know already that we will just take the differentiation f dash x. This is going to be 4x minus k. It is greater than 0 because it is increasing. That means 4x should be greater than k. Or you can say k is less than 4x. Alright. Now x is between 1 and 2. I am saying x, it is given in the question already that x should be between 1 and 2. When you multiply 4, just multiply inside 4, 4 and 8. So x belongs to 1, 2, 4x belongs to 4, 8. So k should belong to where? K should be less than whatever amount 4x gives us. 4x is giving us 4 and 8. So that is the interval which becomes 4 and 8 from 1 and 2 when we multiply 4 with x. So k should be less than 4 because the lowest value of this 4x is 4, highest value is 8. So it has to be less than 4x, which is less than 4. Now what is the interval? It's negative infinity to 4 because till what point you will go? On the left of 4, it is negative infinity. So k belongs to negative infinity to 4. So this is the whole process or the steps which you can follow in order to solve it. Let fx is this one. Be an increasing function on set R, then a and b should satisfy or must satisfy. Okay. When we are not in position in beginning that how are we going to go about it? The only thing which we can do is to differentiate. Let us differentiate this first. F dash x is, this is x cube. It's going to be 3x square. I'm just differentiating normal differentiation. Ax square is 2ax. Bx is b only. So we have this as plus 5. Sin square x is 2 sin x. Then differentiation of sin x is going to be cos x. So we have this 2 sin x cos x can be written as sin 2x. What do we get? 3x square. This is plus. So why did I write negative? It's a slight mistake. I'm making it plus. Plus 2x. Plus b. Now this is going to be plus 5 sin 2x. This is sin 2x. I'll just write it as sin 2x. It has to be greater than 0. What does it mean? Can you sense that this expression is nothing but a quadratic equation? This is a quadratic equation. Ax square plus bx plus c is the standard of a quadratic equation. So the determinant should be less than 0. What is determinant? B square minus 4ac. That is the discriminant. B square minus 4ac should be less than 0. From here we can get the condition for a and b. A is 3 here, b is 2a here, and c is total b plus 5 sin 2x. It is not sin x, it is sin 2x. I have written it, you can just change it. So ax square plus bx plus c. So we have b square minus 4ac. This is 2a whole square minus 4 into a is 3, and then c is b plus 5 sin x, sin 2x. So I've just changed it as sin 2x. It should be less than 0. So 4a square minus 4 is 12, and just multiply inside for 12b, and minus 5 into 12 is 60 sin 2x. This should be less than 0. Okay, now let us divide everything by 4 so that you get a proper equation which resembles the solution. You get a square minus 3b minus this is 15 sin 2x. This should be less than 0. Now coming to the sin 2x. This sin 2x, because what we got is a square minus 3b minus 15 sin 2x. So all those first and second and third term also we got as similar to the options which are being provided here. Sine 2x or sine theta should be less than and greater than certain value, which is -1 and 1. So let us take the minimum value. When we take the minimum value, then only we are going to satisfy this less than 0 term. So in sine 2x, we are going to put -1. I will not put +1. Please remember. -1 because it is the lowest value and we have to check for less than 0. That is why we have taken the -1. So a square minus 3b plus 15, that is the proper solution of this question. Now the whole procedure which you are going to follow to solve it is in front of you. The function fx is equal to log, we have x cube plus under root x6 plus 1 is of the following types. So there are 4 options: 2 of even, 2 of odd, 2 of increasing and 2 of decreasing. So these are all the permutation combination which we see here. So we need to know what is the even function and the odd function. First, that concept has to be cleared. When you put -x in place of x, that is, normally we are taking x, but when we replace x by -x, if it is equal to the original function, it is even. When we put -x and the function gets a negative outside it, that is f minus x is minus fx, this is called the odd function. So this is difference between the even function and the odd function. And then we'll talk about increasing and decreasing. So let us check the even and odd thing first, and then we'll proceed to increasing and decreasing. We have here, I'm placing x as -x here. So wherever we have x, just replace it by -x. So we have log base e. This is x cube plus, so just put minus x whole cube plus under root. This is minus x to the power 6 plus 1. So you don't have to do anything here. Why? Because we know that anything to the power even will be positive, anything to the power odd will be negative. Alright. So we are going to replace anything with even power as plus and odd power as negative. And then we need to solve it. So this is going to be negative x cube. It will be, as I said, that it is power 3 which is odd. And I told you that x raised 6 is basically 2 into 3. Whenever something is 2 multiplied by something, that is, it is going to be even. Anyways, what do you get? We have log here. This is minus x cube. We have plus here. And this is going to be positive x raised 6 plus 1. So we have something which is of a minus b sort. A is under root x raised 6 plus 1. B is x cube. So we have a minus b in the numerator. In this, we need to multiply it by the conjugate. Conjugate means we have a minus b, conjugate of a minus b is a plus b. We have a plus b, the conjugate is a minus b. So we have under root x raised 6 plus 1 minus x cube. So we'll multiply it by under root x raised 6 plus 1 plus x cube. The position may be different, but the basic thing is a minus b. We're multiplying the a plus b, numerator, denominator. Now the numerator will become a square minus b square. That is why we have multiplied it. So a plus b and a minus b is a cube minus a square minus b square. So under root x raised 6 plus 1 whole square minus x cube whole square. So x6 plus 1, this is a square minus b square. So x cube square is x6. So when you get x raised 6 in the numerator, denominator will be x raised 6 plus 1 plus x raised 6, which is the original content inside log. So x6 gets cancelled. You get 1 by something. But when we have log 1 by x, you can write it as negative log x. Why? Because it will be, this 1 by x is nothing but x raised minus 1. When we have x raised minus 1 or x to the power minus 1 will come in front. Anything to the power will come in front of log. So when we take log 1 by something, that will be, what that will be, I just told you. It will be negative log the denominator. So negative log x raised 6, x raised x3 it is, x3. So there is this slight change I have done. Now what is this? This is fx. And what is this? Negative. So when we placed negative x in place of x, then we got the negative of this function, negative of fx. F minus x is minus fx. So this is the odd function. So the answer can be the second one or the fourth one. Alright. So we have to check increasing and decreasing now. Increasing and decreasing means simply differentiation. That is f dash x. So log of that thing, anything which is inside, is 1 by that thing. So 1 by x cube plus under root x raised 6 plus 1. 1 by that thing, right? Now differentiation of this one, which is the above one, that is 3x square plus 1 by twice under root x raised 6 plus 1. Then the differentiation of x raised 6 plus 1 will be 6x raised 5. So 6x raised 5. Okay, then let us take the LCM now. Let us multiply this. So when you multiply this, what are you going to get? 3 to the 6, 6x square into under root x raised 6 plus 1. On the right, when you multiply this, as I'm taking the LCM, 6x raised 5, denominator is twice of under root x raised 6 plus 1. Okay. Now when we get this, we have 1 by x cube plus under root x raised 6 plus 1 in the denominator. Now any cancellation which is possible, if we take this 6 outside and x raised square outside. So let us take 6x square outside. When you take 6x square, it will be x cube plus under root 1 plus x raised 6. Okay. So when we take 6x square, 1x will get cancelled from the denominator. So only 1x will remain in the numerator. So 6x will remain in the numerator, but 2 is also there in the denominator. So it will be 3x finally. And the numerator from which the 6x square has been taken, that get cancelled. So what do you get finally? As I said, we have 6x squared twice and there is a x in the denominator also. So under root x square x 6 plus 1. When you cancel this, what do you get? So final observation, what we find is 3 is positive, x square is positive, under root x, anything with under root will be positive. When everything is positive, what are you going to get? It is greater than 0. This means it is increasing. So what do we see? We have done it in the two parts. First we explained how it is, this function is an odd function, and then we explained why it is increasing greater than 0. Now this question, fx equals to 2 tan x plus 2a plus 1 log sec x plus a minus 2 into x is increasing on r. See, first thing, whatever is inside the log is going to be positive only. But we will take the negative part also in order to complete this solution. The first thing is going to be the differentiation. So I am differentiating this 2 tan x plus 2a plus 1 log and mod sec x. As I said, anything which is mod sec x, so one time will take mod sec x as plus sec x, and one time will take mod sec x as negative sec x. So I am taking plus as of now. Now 1 by sec x, differentiation of sec x is sec x tan x. Then a minus 2 into x is a minus 2. So I am writing sec square x as 1 plus tan square. We know that sec square theta is 1 plus tan square theta, and cosec square theta is 1 plus cot square theta. So we are taking this and just cancel this sec, and what do you get? This as tan x is of course in the numerator, we have a minus 2. Now this 2 gets cancelled. So this, if you assume this tan square x has x only, it is equivalent to a quadratic equation ax square plus bx plus c. This is a quadratic equation which you see here. We have 2 tan square x plus 2a plus 1 into tan x plus a. 2 is a. Okay, if I compare with ax square plus bx plus c, b is 2a plus 1 and c is a. There are 3 terms here. It is greater than equal to 0 because the f dash x should be greater than equal to 0. So what do we have? B square minus 4ac is the discriminant. So the discriminant should be less than equal to 0 in order this for increasing. So b square minus 4ac should be less than equal to 0. That we have done in the previous question also, that whenever we come across these kind of stuff, we see b square minus 4ac is less than equal to 0. This concept we are going to use here. Alright, b square minus 4ac should be less than equal to 0. And if you remember, I told you what is a, what is b, what is c. So 2a plus 1 whole square minus 4 into 2 into a should be less than equal to 0. This is 4a square plus 1 plus this is 4a minus 4 to the 8a. So eventually you got 4a square minus 4a plus 1 less than equal to 0. Now this is nothing but 2a minus 1 whole square. If you square 2a minus 1, you are going to get 4a square minus 4a plus 1. This is 2a minus 1 whole square. And this is less than equal to 0. So just tell me, any term with square, can it be less than equal to 0? No, it cannot be less than 0. It can be equal to 0, but it cannot be less than 0 because it is a square. So what we find here is 2a minus 1 whole square just means 2a minus 1 whole square is equal to 0. That means a should be equal to 1 by 2. A is half. Now this a is half, and this is the answer. The third one is the answer. So just tick that a equals to half. But there is a second scenario also we have to check. That mod sec x was sec x being taken in the first part of our discussion. Now taking sec x as negative sec x when the modulus or the absolute sign is removed. So mod x, the sign is removed, it will become negative sec x. So that I'm going to do. Now this differentiation will remain the same. You know already the differentiation, so I'm not going to go into the detail again. But the differentiation remains like that. dy by dx of fx is 10x is sec square x plus 2a plus 1. Now this is negative now. Log minus sin x. So we have log minus sin x is 1 by sec x. So 1 by minus sec x. Then we have sec x 10x, and then we have a minus 2. Alright. So this is sec x, and we have 2 sec square x minus 2a plus 1. Now just go with the flow and just remember what we have done in the previous part of this question only. This has to be greater than equal to 0 in order for this function to be increasing, because the differentiation is greater than 0. So only this negative has changed, other things remains the same. This sec square x, just write it as 1 plus 10 square x. In the previous part also we did the same thing. So that we can cancel these two, the first one and the last one. The 2 into this, multiply this inside 2 10 square x, and I have cancelled 2. I've already cancelled it, okay? That is why I have written 2 tan square x. This is minus 2a plus 1 tan x plus a greater than equal to 0. That means b square minus 4ac should be less than equal to 0. Again same thing which you do here. Again ax square plus ax square minus bx plus c is the quadratic equation here. So what is a, what is b, what is c, you already know that. So b I am writing it as negative 2a plus 1. b square minus 4ac is what? Same term which we used in the previous part, only the negative is there, negative 2a plus 1 whole square. But since it is square, b is square, and b here is negative. So again 2a minus 1 whole square will be less than equal to 0, which is impossible. You can only get 2a minus 1 equal to 0, not less than equal to 0. So a will be equal to half. So this is for the sake of completion. First part you have already known, a equals to half was already the answer which we have discussed. You can just check this and tick this. So how you are going to go about it? This is the whole procedure of solving this question. Every step I explained you. Only mod x should be taken as x and negative x as separate cases which we took, but both the cases gave us a equals to half. Fx is tan inverse gx, where gx is monotonically increasing in 0 to pi by 2. Then fxx monotonically increasing means in a similar pace it is increasing. The average speed remains the same. That is what is monotonically increasing. Exponentially means it is increasing very fast. We have gx equals to, this gx is basically increasing 0 to pi by 2. So what is the definition of increasing? If you remember, when we started the first exercise, I told you we take two numbers x1 and x2, where x1 is less than x2. When x1 and x2 are belonging to this interval which is 0 to pi by 2, this x1 and x2 is belonging to 0 to pi by 2, gx is monotonically increasing. So when we have x1 less than x2, that defines the monotonically increasing function as the gx1 should be less than gx2. That is, x1 is less than x2, gx1 is also less than gx2, that is monotonically increasing. Okay, so that is the definition. If x1 is greater than x2, gx1 should be greater than gx2. That is the whole idea. Now I am taking both sides tan inverse. Now just remember that we are talking about the interval 0 to pi by 2. What is tan inverse 0? What is tan inverse pi by 2? Tan inverse 0 is what? It's 0. Tan inverse pi by 2 is what? It is increasing. So it is increasing. Tan inverse content, when you have a value which is less than x1, if it is less than x2 in this 0 to pi by 2, the tan inverse of gx1 and tan inverse of gx2 is also less than, because I told you tan inverse 0 is 0 and tan inverse pi by 2 is infinite. So it is actually increasing. So monotonically increasing, this tan inverse is also increasing. You know the values of tan inverse, the cos inverse and the sin inverse of different values. But this whole means fx1. So fx1 is less than fx. So we started with x1 less than x2 and we proved that fx1 is less than fx2.
What does it mean? It means that this is also increasing. The inequality hasn't changed. So that is the answer. Now I'd like to show that why it is increasing in 0 to pi by 2, which is the answer here, which is the first one. The first option is the correct answer here. So this diagram plays a very important role in solution, right? Let fx equals to x cube minus 6x square plus 15x plus 3. Then now there is certain things which we have already explained. So we'll use those concepts directly here. Okay, so let us use it here. We have f dash x equals, we are differentiating it 3x square minus 12x plus 15. So this is the f dash x. Now we have 3 outside, so let us take 3 outside, x square minus 4x plus 5. Now let us make it as a perfect square, because if we can make it as a perfect square, we can show it is increasing. So x square minus 4x, I am writing 5 as 1 plus 4 or 4 plus 1. So I am writing 5 as 4 plus 1. This first part, x square minus 4x plus 4, is nothing but x minus 2 whole square plus 1. So you can write it as 3 into x minus 2 whole square plus 1. So what do you get here? First of all, this 3 is positive. X minus 2 whole square is positive. Anything added with the positive value will again be positive. I am saying we have manipulated or modified this equation in such a form that we can tell that this equation will always be greater than or equal to 0. That is 3 positive. X minus 2 whole square, because anything square, I already told you, anything with the square will always be positive. So it is x square plus something. So you are adding something, you are not subtracting. So when you add 1, x square plus 1, so it is strictly increasing. Then you have 3 multiplied, and this whole is greater than 0, it is strictly increased. So when you have strictly increasing, that means f inverse exists. That I told you in the beginning of the discussion of this chapter. That if a function is increasing, it is strictly increasing, that means the inverse also exists. So when the inverse exists, the third option, which is fx is increasing, can be used. Invertible function. So what we have done here, the finally things come down to the option says fx is invertible. So this is how you are going to do this. The function fx equals to x square e raised minus x is monotonically or monotonic increasing when. So when it is greater than or equal to 0, what will be greater than or equal to 0? Tell me what is greater than or equal to 0? It is f dash x. That is the differentiation. So first thing we have to do is the differentiation. So we'll use the product rule. First x square, differentiation of e raised minus x. So e raised minus x, then differentiation of negative x is negative 1. Then we have e raised minus x like that. X square differentiation is 2x. So e raised minus x I am taking outside, and this x I am taking outside. Again x taking outside. So x into e raised minus x. We have 2 minus x. Now you can take 2 outside common. So I am taking x. I am making x 2 minus x as x minus 2, because it is saying that f dash x is greater than 0. So when you have greater than 0, what are you going to get? E raised minus x. E raised minus x is what? See, e is a constant number. I told you already in the previous discussion. E is 2.174. Now anything with a constant power, that is, you have e raised minus x, x can be anything. X can be any value, but if it is of the power of 2.17, even if 2.17 is in the denominator, it will always give you a positive number. I am saying e raised minus x will always be greater than 0, whatever be the case, whatever you put in place of x or replace x by any value. Now x into 2 minus x is the thing which we need to understand. So x into 2 minus x is greater than 0. I am multiplying both sides by negative 1. What do you get? It is less than now. So this, if I multiply both sides by negative 1, what will be there? X into, if I multiplied negative, I am making now 2 minus x as x minus 2. So x into x minus 2 is less than 0. Now let us take this x into x minus 2. I told you when you have 2 factor and when they multiplied is less than 0. So either one is positive, second is negative, or the first is negative, second is positive. When this x in x minus 2 is going to be 0, x is 0 at x equal to 0, x minus 2 is 0 at x equals to 2. So when we have this a into b less than 0, we take the internal part, that is between 0 and 2. So x should belong to 0 and 2. X should belong to 0 and 2. So x is between 0 and 2. Okay, this is your final answer. Now function fx is equal to cos x minus 2 lambda x is monotonic decreasing when? What does it mean? Decreasing. That is, it is
less than 0. So f dash x greater than 0, it is increasing. F dash x less than 0, it is decreasing. F dash x is simply differentiation, so we are differentiating it right now. Cos x is minus sin x, minus 2 lambda x is minus 2 lambda. So this is monotonic decreasing. So it is less than 0. So we are not dealing with negative. So I'm taking minus outside. It is less than 0. Multiplying both sides by -1. The inequality sign is going to change and the negative sign will become positive sign. So this inequality will change. It will remain 0. This is going to be sin x plus 2 lambda. So this 2 lambda is greater than negative sin x, and then we have this negative, just multiply this one, -1. So when you multiply this negative both the sides, let's make it positive because dealing with this negative creates certain problem. So minus 2 lambda is less than sin x, and this sin x, see again, sin x is between -1 and 1. That is the highest and lowest range of sin x is -1 and 1. So this x is less than sin x, or say y is less than sin x. What does it mean? Something is less than the minimum value of sin x. What is the minimum value? -1. So minus 2 lambda is less than -1. Again multiplied by -1 on both the sides. So this inequality will change. It is going to be 2 lambda 1. So lambda is greater than half. So this lambda is greater than half is the option being provided, and that is what we are going to use. So this is how you are going to go about it. So this dealing with negative may create certain problems. So always get rid of negative and then solve the way we have solved it here. Just differentiation and getting it greater than 0. In the interval 1 to 2, function fx is this. First thing is that we are talking about 1 and 2. How this 1 and 2 has come? Because the modulus has x minus 1 and modulus has x minus 2. So x is between 1 and 2, it is given in the interval. That is, anything has to be greater than 1 and less than 2. So x is greater than 1 and x is less than 2. When you take 1 on the left, you will get x minus 1 is greater than 0. Here you will get x minus 2 is less than 0. So we haven't gone to the question yet. I am just talking about interval right now. And from that we got x minus 1 greater than 0 and x minus 2 less than 0. And you know mod x is x when x is greater than 0 and mod x is negative x when x is less than 0. This is the definition of this mod x. Coming to mod x minus 1. See, x minus 1 is greater than 0. I just showed it. So x minus 1 modulus is x minus 1 only because x minus 1 is greater than 0. Mod x minus 2, it is less than 0. See, this is going to be minus x minus 2 because it is less than 0. It is already, I've showed that the value is between 1 and 2 only. So these two you have to replace. Mod x minus 1 by x minus 1 and mod x minus 2 by negative x minus 2. So 2 into x minus 1 plus 3 into negative x minus 2. I'm writing it x minus 2 here. Okay, what do we get here? 2x minus 2 and this is minus 3x and plus 6. So what do you get here? 6 minus 2 is 4 and 2x minus 3x is negative x. So it is 4 minus x. fx is 4 minus x. Now let us differentiate it now. This is interval. We have removed the modular sign. Now coming to the differentiation. When we differentiate, you will get minus 1. Now minus 1 in any cost is negative only. Negative 1 is less than 0. So when we have x between 1 and 2 and we got f dash x which is negative 1 which is less than 0. That means, see, it is not less than equal to 0. It is actually less than 0. That's why it is monotonically decreasing because it is less than 0. F dash x, if it is less than 0, then you can say that it is monotonically decreasing. This is how you are going to do this. This is the whole process you are going to follow. So there are certain things which I have added up and you can just draw the diagram and show. It would be very beneficial for you if the diagram is being made. Function fx equals to x cube minus 27x plus 5 is monotonically increasing when? So the question is saying that it is monotonically increasing. So the concept here is, we'll differentiate first. That is the first thing we do. F dash x is 3x square. This is minus 27. So 3 you can take outside. It will be x square minus 9. And this is x square minus 9 is simply x square minus 3 square. That is x minus 3 into x plus 3. A square minus b square is a minus b into a plus b. So x minus 3 into x plus 3. This is your f dash x. Now this is increasing, monotonically increasing. So it is greater than 0. 3 into x minus 3 into x plus 3 is greater than 0. And you know now 3 is, there is no point in discussing 3 because it is already positive. X minus 3 will be 0 when x equals to 3. X plus 3 is 0 when, because x is equal to minus 3, then only 1. So we are going to write 3 and minus 3. I've just written it negative 3. I'll just change it. Okay, there is a slight change I'll make. But if you see a into b is greater than 0, a and b are the factor. That is anything which is below minus 3 and above plus 3. That is what is the answer will be. If it is less than 0, a into b is less than 0, then we take things which are inside between 3 and
minus 3. So we have two ranges here, or two intervals. Negative infinity to negative 3, I'll just change it here, and positive 3 to positive infinity. So minus 3 to minus infinity to minus 3 and 3 to infinite, or you can say this x is less than minus 3 and x is greater than 3, which is the solution when we have two factors multiply, one is plus and one is minus. So x less than minus 3 and x greater than 3. Now take the modulus. When you take the modulus, this x will become again greater than 3. You know about that. A modulus, there is no point in discussing modulus of a positive number here. 3 is a positive number, but negative 3, if you take the modulus, the inequality is going to change. So both the times you are going to get mod x is greater than 3. Okay, because mod x is x when x is greater than 0, negative x when x is less than 0. That shows that mod x is greater than 3. So all this solution has given us what? It's x mod x is greater than 3. There are four options here. X is less than minus 3 is the solution. X less than equal to minus 3 is not. Mod x is greater than 3 is the solution. It's not greater than equal to 3. Second option may be chosen. Fourth option should be chosen. So it is monotonically increasing, that is why it is greater than. 2x cube minus 9x square plus 12x plus 29 is monotonically decreasing when? So when we are decreasing, what do we do? It's fx. We'll take the differentiation. It is going to be 6x square minus 18x plus 12. Now take 6 outside. You're going to get x square minus 3x plus 2. So x square minus 3x plus 2. X square minus x minus 2x plus 3. X minus 1. And you can take minus 2 here. So you will get x minus 1. So x minus 1 into x minus 2. So this is quite easy now. X minus 1 into x minus 2. So 6x minus 1 into x minus 2. It is monotonically decreasing. So just make it as less than 0. And when I told you that we have two factors, 6 cannot be less than 0. So whenever this x minus 1 is 0 is x equals to 1, x minus 2 equals to 0 is x equals to 2. So 1 and 2 are the critical points. So whenever we have two factors which is less than 0 when they are multiplied, we always take the things which are between certain values. I told you when it was greater than 0 in the previous question, I told you that less than 1, that is negative infinity to 1, and 2 to infinity. That was the point, that was the explanation there. But now here it is less than 0. X minus 2 and x minus 1 into x minus 2 is less than 0. So we'll take 1 and 2 is the interval. So x lies between 1 and 2. And so this is the monotonically decreasing when x is going to be between 1 and 2. That is going to be that. So this is the whole process you are going to apply here. And this is quite an easy question for you. So this question, fx is monotonically increasing in every interval then. So these are the different options you have. Monotonically increasing in every interval. So the first thing what we do generally, tell me, we just differentiate it. So we are going to differentiate it here also. This f dash x is equal to 3kx square minus 18x, and then we have plus 9. So I'm taking 3 outside. You'll get kx square minus 6x plus 3. Okay. This monotonically increment means what? F dash x should be greater than 0. This whole should be greater than 0. 3 cannot be less than 0 or greater than 0. It is a constant. It is already greater than 0. So kx square minus 6x plus 3 should be greater than 0. Okay. So this, since the value is not given, so here we'll use the concept of the determinant. See, there are certain things which comes up in the question which is different from what we have been doing. So if we have ax square plus bx plus c is the quadratic equation, if it is greater than 0, what does it mean? It means a greater than 0, a should be greater than 0, and determinant, which is b square minus 4ac, should be less than 0. Two things here. I have introduced a new concept which we have already discussed in the previous chapters. So a should be greater than 0 and b square minus 4ac should be less than 0. Okay, what is a here? K. B is minus 6. C is 3. If you compare this equation, quadratic equation, with ax square plus bx plus c, you will get this thing. So we'll just say that this k should be greater than 0 because a is greater than 0 is the first thing which I told you. Second thing is b square minus 4ac should be less than 0. A is k, b is negative 6 and c is 3, which I can reiterate now. And I'm now replacing the value b square minus 4 into a, that is k, and this is 3. So this is less than 0. 6 is 36 minus 12k less than 0. 36 is less than 12k. 12k, that is k, is 12k is greater than 36. K is greater than 36 by 12, which is k is greater than 3. So when you have two options, k is greater than 0 and k is again greater than 3. So if you combine this, if you're saying something is greater than 0, something is greater than 3, That means it is greater than 3. It's greater than 3 if we combine these two. So k is greater than 3 is the correct option which we are going to choose here. Alright. So this is the step-by-step solution which you can see here. And this thing is a new thing which you must know. Otherwise it won't be able to be solved by itself, right? You have to take these two things into point. F dash x greater than 0 is already there, or less than 0 is already there. Now here the differentiation will take some effort, but monotonically increasing is simple with what we have been doing. We just differentiate it and we take it as greater than 0 because it is increasing. So first thing is f dash x. Let us take the differentiation. 2 tan inverse x is 1 by 1 plus x square. Log content anything is 1 by that thing. So 1 by x plus under root x square plus 1. Differentiation of x plus under root x square plus 1. So it is going to be 1 plus 1 by twice of under root x square plus 1. Under root x square plus 1. Then differentiation of x square plus 1 is 2x. So I've written the differentiation. Now there's only one thing you have to do is to take the LCM and you have to rearrange. You know how to simplify this. So I will just leave it for you because I hope that this is a customary and routine things which you have been doing. I'm going to write the final thing which you get because it will take some certain time to solve it. So I'll just write the final thing. 1 plus 2x square minus under root x square plus 1 divided by 1 plus x square. This is after the simplification. You are going to get this thing only. Now this is greater than 0. This is given in the question. This is greater than 0. 1 plus x square will always be greater than 0. Anything with an even power is going to be greater than 0. So even if you add 1 with x square, it doesn't affect. So 1 plus x square will be greater than 0 eventually. What is the numerator? 1 plus 2x square is greater than under root x square plus 1. This is the what you get in the numerator. Now take the square of both the sides, 1 plus 2x square whole square and x square plus 1. Now just open this. It will be a plus b whole square. So a square plus b square plus 2ab. You can use the formula. There is no extra 2ab. This is a formula. You multiply it 2 times, then you get 2ab. There is no extra 2ab. Okay. So what do you get? 1 gets cancelled. And you have 4x raised 4 and this goes here. It will be plus 3x square greater than 0, and this is greater than 0 because x has even power. One term has x raised 4, one term has x raised 2, x raised 4 and x raised 2. So anything with even power will always be greater than 0. Alright, so this is the x raised to even. Now these both are positive. 1 plus x square was already positive, so whole this numerator denominator or whole term on the left is greater than 0. So if you put anything in the x, this function will always be monotonically increasing. It doesn't matter. So you can put anything, and anything is what? Real numbers. Real number, anything which can be placed on number line. It can be 0.1, it can be minus say 2.3, it can be 1 by 98, it can be any number which can be represented on the real number line or number line. So this real number is the solution. X should belongs to real number. That's how this function is going to monotonically increase. So you have proved that the term on the left when you took the f dash x is greater than. Differentiation will be done by you. Okay, so this will take some effort, but I hope you'll be able to do it. So this is the whole option. This is the whole thing which you are going to do. Alright, so x belongs to R is the answer. Now we have this mod x and mod x minus 1 is monotonically increasing value. So before that, there will be certain cases here. So if you see all these options, very carefully see the 4 options being given. So what do we have? X and x minus 1. When it will be 0, this mod x, when x is 0. When will x minus 1 equals to 0? When x is equal to 1. So this 0 and 1, these are the point on which we can devise 3 cases. So x when it is less than 0, when x is between 0 and 1, and when x is greater than 1. I hope you got the idea. X is less than 0, x is greater than 1, and x is between 0 and 1. So when x is less than 0, this is case 1. When x is less than 0, by definition mod x is going to be negative x. X is less than 0, mod x is going to be minus x. How about mod x minus 1? When x is less than 0, you can just try putting any value because it is less than 0. So it's going to be what? It will be negative. So it will be minus x minus 1. So for x less than 0, you can put any value. Try it also. Mod x minus 1 is going to be minus x minus 1 in this case. Okay, I'm saying if you put negative 1, say for example, it will be negative 2. So what will be that? It will be negative of 2 negative x minus 1. So this case 2, case 3. Again, these three cases I am going to show side by side between 0 and 1. Now we have come between 0 and 1. X is 0 and 1. We have come to the positive side. So mod x is going to be positive x. But still, this mod x minus 1, you are subtracting from 0 to 1. Any number between 0 to 1, you are subtracting that number. The 1 is being subtracted from that. So it will be negative. Okay. You can put any value. Say you just put say 0.5. So 0.5 minus 1 is negative 0.5. So it is going to be negative. Mod x is going to be positive. I hope you got the idea. Take any value between 0 and 1. Place in place of x. If I take 0.5, it is going to be minus 0.5. So mod of negative 0.5 is going to be negative of x minus 1. Mod forcefully makes a value positive. So you have to place a negative to make it positive. How about this is third thing, which is if you're going above 1, of course, mod x is going to be x only, it is positive. And when you are between above value of 1 and you put any value of value above than 1, say put 2. So 2 minus 1 is 1 and mod of 1 is 1 only. That is mod x minus 1 is going to be x minus 1. So third case we took was x greater than 1. Alright. Now let us differentiate. But for that we have to make the function. Fx is going to be, now we already have the non-mod values. Just replace it. Minus x, minus of minus is plus, x minus 1. So you can cancel this. It is going to be negative 1. So just differentiate this f dash x. When you differentiate it, it is going to be 0. And f dash x is equal to 0. It is not greater than or equal to 0. It is equal to 0. I hope you got the idea. So it is you who are going to decide what options you are going to take. Second thing, fx is equal to, now x, in place of mod x minus 1, you can write minus of minus x minus 1. So plus x minus 1. This is 2x minus 1. When you differentiate this, it's going to be 2. So it is not greater than or equal to 0. 2 is actually greater than 0. 2 is actually greater than 0. Now third option is what? Fx. We have x here. Mod x minus 1 is of course x minus 1. So this is again, this gets cancelled. Fx is 1. F dash x is going to be 0. So this is not greater than or equal to 0. It is actually equal to 0. So in the first case and the third case, we got f dash x equals to 0. But in the case number 2, f dash x is actually greater than 0. It is not equal to 0. So there are three options here. First and third option gave us equals to 0. The middle option, which is x between 0 and 1, has given us what? It is actually greater than 0. So what do you suggest? So we have all the options here. Three options we have taken. You can just forget about this x less than 1. So x less than 0, x greater than 1, and x between 0 and 1. All these three options or three cases, we have seen that what options you can choose. If it is increasing or monotonically increasing, there is a difference. There is a difference between increasing and monotonically increasing. The question could have said that it is exponentially increasing. Monotonically increasing has certain value or added this certain value to this question. We have three cases here. 2 times we got equals to 0. 1 time we got it is greater than 0. So what do you think? These are the three answers you can have. These are the three options. But the R.D. Sharma has given it is X. The options which are being provided or the answer which is provided by R.D. Sharma is this. Now you have to decide what options you are going to choose. If it is increasing, we choose X less than 0, X greater than 0 and X between 0 and 1. Alright. So this is the whole idea or scenario which I want to highlight. That certain questions, it's up to you that what options you are going to choose depending upon whether it is a 2 marks question or more than that number of questions. So this is the x between 0 and 1 is the, if you have to choose one, x between 0 and 1 is the best suitable answer. Otherwise, the first, second and third are the better options if you choose all of them. So this is the whole one. It is not monotonically increasing. It is monotonically increasing between 0 and 1. Every invertible function is, so we have seen previously also, every invertible function is what? It is a monotonic function, because in previous question also I told you it was a reverse, that this function is monotonically increasing and the option was f inverse exist or f is function is invertible. So if it is invertible, that signifies or that indicates that we are dealing with the monotonic function. So this is how we are going to write.
In the interval 1, 2, function fx equals to twice of x minus 1 plus 3x minus 2. This x minus 1 and x minus 2 are in modulus. So we are talking about the interval which is 1 and 2. First of all, mod x is x when x is greater than 0. It is negative x when x is less than 0. This is a very important thing that has to be very clear to every one of you. Now when you have mod x minus 1, now just put any value between 1 and 2. For example, I take 1, I take 1.5, I take 2. Now just subtract 1, what do you get? You'll get 1, you'll get 0.5, you'll get 1. So you'll never get a negative value. So in between 1 and 2, mod x minus 1 will always be positive. So it will be positive. I hope you got the idea. Coming to mod x minus 2. Now just put any value between 1 and 2. Again, same values I'm going to take. 1 minus 2, 1.5 minus 2 and 2 minus 2. What do you get? You get a negative 1, you get minus 0.5 and a 0. So every time you get a negative 1. That means mod x minus 2, in particular this 1 to 2 interval, will always be negative. I hope you got this idea, because when it will be positive and negative in this interval. So I'm now replacing this x minus 1 by x minus 1. Or you can say modulus x minus 1 by x minus 1. And modulus x minus 2 by negative x minus 2. So I've made it as negative. So when you open this, you'll get 2x minus 2 minus 3x plus 6. So we have 6 minus 2 is 4 and 2x minus 3x is minus x. So this is fx. Now let us take the differentiation f dash x. It is going to be negative 1. F dash x is negative 1. Now this negative 1 is less than 0. Whatever you do, it is a constant. It will always be less than 0. That means this function, whatever you do, it will always be decreasing. When f dash x is less than 0, it will always be decreasing. Negative 1 is negative. It is decreasing. So this is the solution reference for you if you want to do it by yourself. If the function fx equals to cos modulus x minus 2x plus b increases along the entire number scale, then number scale, we are talking about number line. So this function is increasing. It increases. What does it mean? First of all, we have to find a relationship between a and b, or a relationship of a with certain numbers. These are the 4 options being provided. The first point of concern is the modulus x. And again, same thing I'm going to reiterate. Modulus x is x when x is greater than 0. It is negative x when x is less than 0. Alright. So minus x, why it is? Because if something is negative, negative to make it positive, you always put a negative. That is why minus x. Because mod x, always the input can be any number, but the output will always be a positive number. Okay. Negative, put positive, you'll get a positive. Put negative, you'll get a positive. Every time you get a positive. So now we have cos modulus x. What is mod x? It can be x, it can be negative x. So it can be, the mod x is x when x is greater than or equal to 0. You already know about this. And it can, the cos x can be replaced by negative x when x is less than or equal to 0. Not equal to, sorry. X less than 0. X greater than 0 for positive. X less than 0 for negative. Now you know what is cos minus theta. Cos minus theta is plus cos theta. Sin minus theta is minus sin theta. But cos negative theta is cos theta. So both the ways, if x is greater than 0 or less than 0, you'll always get mod x as positive. Alright. So we don't worry about modulus x. You can just replace modulus x by positive x. So we have cos x minus 2ax plus b. And now we'll differentiate it. F dash x is going to be cos x is minus sin x. This minus 2ax will give you minus 2a. This is going to be 0. So this minus sin x minus 2a. Now this is increasing. That means f dash x is greater than 0. So what is greater than or equal to 0? We have minus sin x minus 2a is greater than 0. Minus, I'm taking minus outside. See, I'm not telling you to deal with it, but I don't deal with negatives. Because always the solution goes in other way. So I'll always deal with positive. So I'm multiplying both sides by negative, and I know when I multiply with negative on both the sides, the inequality is going to change. So this is sin x plus 2a is less than 0. So sin x is less than 2a, negative 2a basically. 2a. Again, I get a negative here. Please remember, this is less than or equal to 0. Okay, just because to meet the options, I am making it as less than equal to minus 2. So finally, you can just replace it. You can multiply a negative, or you can say multiply both sides by negative. This is, I'm not saying you to do it. I'm just doing it for myself because I don't deal with negatives. And multiplying both sides by negative will always change the inequality sign that has to be fed into your mind. Alright. Now tell me, what is the highest and lowest value of sin x and cos x? It's plus 1 and negative 1. So 2a is less than equal to negative sin x, and we need a relationship between a and certain value. But sin x minus 1 or plus 1. But if you say I am lower than the lowest value of yours, or I am higher than the highest value of yours, that is, if I am higher, I am higher than 1. If I am lower than minus 1. That is the whole limit of sin x. So minus 2a is greater than equal to 1, because the highest value of sin x is 1. So when you make a relationship here, again you can multiply by negative, which I generally do. But my idea is, again minus multiply, you will get a less than equal to negative half. Okay, I'm not saying you to multiply negative. I'm just doing it for myself. I'm just doing it to get rid of negative and just changing the inequality. So finally what you'll get is a should be less than equal to negative half. All this is not what you have to do. This I did for myself. Again, I'm reiterating. But finally, when you'll solve it, you'll get that a should be less than equal to negative half. A is less than equal to negative half. So this is going to be your answer. The third option is the correct answer. Okay, this is the solution reference for you. And all these things you know already. Only if you go along with the concepts which if you are following me, you know all these concepts now. So this is how we need to follow. Greater than equal to 0, a less than equal to minus half. The function fx equals to x by 1 plus modulus x is, okay, strictly increasing, strictly decreasing, neither increasing nor decreasing, none of these. So they haven't provided us the domain. So we have to find out the domain by ourselves. What is the interval? No, we don't know what x can be placed. So we have to take the cases now. Why? Because modulus x, again, two things will come, negative and positive. So x can be greater than equal to 0 or x should be less than 0. These are the two cases for modulus x. And you already know, I've been writing it many times. Mod x is x for x greater than 0, negative x for x less than 0. This already you know. So this x is greater than equal to 0. Mod x will be x. X less than 0, mod x is going to be negative x. This you already know. Now replace this x by 1 plus x here. This is your fx. And here you will get fx equals to x by 1 minus x. Because now in the case 2, x is less than 0. And by the definition of modulus, you have to take a negative. Now let us differentiate. And you already know the differentiation of x by 1 plus x. We have already completed this in our previous discussion. So I am writing the value directly. 1 by 1 plus x square. F dash x of x by 1 minus x is 1 by 1 minus x whole square. Now any value, I told you already, if you take any value and square it, it will always be positive. There can be no reason. Or you can say not square, but anything with the even power will always be positive. So this is, you have square in the denominator. So always positive. Greater than 0 here. Here also greater than 0. So in both the cases, what we got is, it is strictly increasing because the f dash x, which is the differentiation of this function in both the cases, is greater than 0. Greater than equal to 0 is just increasing. Greater than 0 is strictly increasing. So first option should be taken. Now this is the solution reference for you. You can follow this if you want to do it by yourself, and all the content which I have told you, the explanation, you have to write it, right? All right. Don't use the solution directly. Please, I encourage you to do it by yourself. If you are stuck, then you can come here. The function fx equals to this one, lambda sin x plus 2 cos x by sin x plus cos x, is increasing if. So this fx, we will differentiate and we will keep it or put it greater than 0, and we will get the value of lambda with certain relationship with other numbers. So we have done so much of differentiation up till now that I leave it to you for the differentiation. That is, it will save your time and my time also, because f dash x differentiation you already know. So let me write the differentiation. See, whatever I am writing right now is the differentiation of lambda sin x plus 2 cos x by sin x plus cos x. So you have minus 2 plus lambda divided by sin x plus cos x whole square. This is differentiation. Now we have to equate it, or to tell that it is greater than 0 for increasing. That is what is the relationship we get when it is increasing. Anything with a power even will always be positive. So the denominator sin x plus cos x whole square is positive. So what do you get? Lambda minus 2 in the numerator. It is greater than 0 because if numerator denominator is greater than 0 and denominator is greater than 0, numerator has to be greater than 0. So lambda is greater than 2. This is the option which you have to choose. So I saved the time by not differentiating it. And differentiation, but I'll tell you, I'll show you, okay? Because if I do the differentiation, it will not help you. You have to differentiate by yourself. So this is the whole differentiation which I'm showing right now. And this is the concept which I used in order to show that lambda should be greater than 2 for this function to be increasing. Now this question is quite straightforward. Whether it be exponential or whether it be log, they follow the same procedure and rule. A raised x is increasing on R. That is, a should be greater than 1. A raised x will be decreasing when a is between 0 and 1. This you already know, and this goes along with log also. But we'll follow the steps. F dash x I am finding out. A raised x differentiation is a raised x log a, base is e. This is greater than 0. Log a is a should always be positive if you are talking about log. You cannot have a as less than 0. So a should be greater than 0. A raised x will whatever value you put, a is a constant here. So whatever value you put, a cannot be less than 0. So anything greater than 0 to the power x, any value will always be positive. And the second term is log a should be greater than 0. I'm not writing greater here. I'm equating it now. That means e raised power 0 is equal to a. E raised power 0, anything to the power 0 is 1. So a is greater than 1. Now let us replace it by the greater than sign. A is greater than 1. So you get a greater than 1. So these are the different options which you can do here. So concept I told you, all proving and all writing is what I have spoken. A raised x should be greater than 0. Log a should be greater than 0. And from there, we devise and finally claim that this is only possible when a is greater than 1. Again, this is a simple thing which you have learned. Log ax, a is base, x is the value for which log has to be taken, but the base is a. Now in both the case, a should be greater than 1 for increasing and a should be between 0 and 1 for decreasing. You already know that. So let us continue our work. Fx is log base ax. We'll differentiate it. When we differentiate it, what do we get? 1 by x log a. See, simply you can write log ax as when you take base e, it is log x by log a. Base is e. This is how we can do. You know the properties of log. Log base e a is a constant. So there is no point in differentiating it. You just have to differentiate log x, and log x differentiation is 1 by x. That is how the differentiation 1 by x log a has come up. Okay, so 1 by log x log a has come up. Okay, 1 by x log a greater than 0 because it is increasing. It is given on R. R is what? Is the real number. So what do we get? See, if it is greater than 0, x has to be greater than 0 and log a should be greater than 0. Base is e. E is what? E is 2.7. And something number. You already know that. So 1 by log x is log x a. We already know that this a should be between what? X can be any real number. X can be a real number. It can be positive. It can be negative, whatever. But we are not dealing with x. They are not asking. The 4 options being provided is not about x. We can straight away say x should be greater than 0. But the 4 option is related to a. So we have to talk about log a should be greater than 0. Log base e a should be greater than 0. And this log a is only defined when a is greater than 0. And see, a is greater than 1 when it is increasing. And a between 0 and 1 it is decreasing. What is the option? A greater than 1. Okay. So a should be greater than 1 is the option for increasing on R. We would have talked about x. Definitely we should talk about x, but the 4 options being given is not related to x. So we have to talk about log a. So this is the whole explanation and writing which you have to do. I hope you'll be able to do it. Let 5x equals to fx plus f2a minus x and f double dash x is greater than 0 for all x which is belonging to 0 to a. Then 5x. X is between 0 and a. You have to talk about 5x and you have to tell about the interval where it is increasing or decreasing. The options are 0, a, minus a, 0, a, 2a. So 5x is given as fx plus f2a minus x. The best thing is to differentiate it. Let us differentiate it. So f dash x you can write here. You can write it as f dash 2a minus x, and then the differentiation of 2a minus x which is minus 1. Okay, so just I'm replacing it. I don't write, I don't write many steps. I do it here only. So I just placed it as negative. This has to be written separately, but I have just written it just to save our time. So now f double dash x is greater than 0. What does it mean? F dash x is increasing function. F double dash x, because this is not a question of this chapter, because double differentiation we have not dealt with in this particular chapter. But let me tell you the concept. If the double differentiation is greater than or equal to 0 and f dash x that simply means f dash x or differentiation of f is increasing. All right, so we will introduce a new thing here in order to prove this all, because there are various things being given here and the concept is very clear. F double dash x greater than 0, that is f dash x is greater than 0, which is increasing. So we are talking about 0 and a. So here what do we get? X is, because the interval is given as 0 to a, so x is less than or equal to a, which is given here. Let us multiply both sides by 2. You get 2x is less than or equal to 2a. 2x can be written as x plus x. X plus x is less than or equal to 2a. Let us take x on the right hand side. So x is less than or equal to 2a minus x. Now let us take both sides by f dash x. I am taking, it will not make any difference. I am taking f dash x on both the sides. So what do we got? F dash x is less than or equal to f dash 2a minus x. But if you remember, we have already differentiated it. Phi dash x is equal to f dash x minus f dash 2a minus x. But this is 1, this is 2. From 2, what do we get? The first value is lower than the second value. I hope you got the idea. From second, the equation which is the second one, it proves that the first term is less than or equal to the second term. If you take the number, let me show you by, that is 1 is less than 2. So when you subtract this 1 and 2, you'll get a negative. Okay, because the first one is lower than the second one, so you'll get a negative 1. So f dash x will be always equal to less than or equal to 0. That is, you are getting a negative 1. So it is less than or equal to 0. This phi dash x is less than or equal to 0. Alright. So this phi dash x is less than or equal to 0. That means we are talking about the decrement. If any differentiation of any function is less than or equal to 0, that means that function is decreasing. But this is decreasing where? In which interval? This phi dash x is less than or equal to 0. That is, it is decreasing in 0 to a interval, which is already given in the question. Alright. So in this interval 0 to a, it is decreasing. That what we can prove here, because most of the things are not given and f double dash x is not pertaining to this chapter. So whatever we could do, we have presented here, and that is the concept. So this is how you are going to go about it. You have to write everything, which is very important. The concept remains the same. If the function fx equals to x square minus kx plus 5 is increasing on 2, 4. So k belongs to this k we have to find out. This belong to where? This is the thing which we have to answer. But the only thing what we can do here with our concepts is we'll differentiate it. F dash x is differentiation. X square is 2x minus k. So f dash x is 2x minus k, and 2x minus k increasing, so it has to be greater than 0. So 2x minus k can be greater than 0, so 2x should be greater than k. So k should be greater than less than 2x. Now this is 2 and 4. It varies from 2 to 4. So you can give x, the lowest value is 2. You can give x the highest value as 4. So k is less than 2 into 2, which is 4. You can replace x by 2 and x by 4. So x is less than 2 into 2 and this k is less than 2 into 4. So k is less than 4 and k is less than 8. So this, if any number is less than 8 or less than 4, that means it is less than 4 only. If my height is lower than yours and your height is lower than your brother's, then my height is lower than your brother's. So k is between minus infinity and 4. So this is the solution. Very straightforward here. If your concepts are clear, you will understand this. Fx equals to minus x by 2 plus sin x defined in minus pi by 3 and pi by 3. Minus pi by 3 and pi by 3. Pi by 3 is 60 degree, and we are talking about negative 60 degree. That will be the mirror image of 60 degree if you make that thing or try to show that thing in the Cartesian coordinate system. F dash x is what? Let us differentiate this first. F dash x is minus 1 by 2 and sin x will be cos x. This is your f dash x. Now you have to tell whether it is increasing, decreasing, constant, or none of these. And the interval is also provided to you, which is negative pi by 3 and pi by 3. So let us come to because we don't have anything. We don't know whether it is less than 0 or greater than 0. So we just have to deal with the interval. See, cos pi by 3 is 60 degree and cos minus pi by 3 because cos minus theta is plus cos theta. So even if you put cos minus pi by 3, you're going to get half only. Cos negative theta is cos theta, and if you take sin minus theta is going to be negative sin theta. But the first quadrant and the 60 degree, let me draw it. 60 degree is this one. What will be minus 60 degree? It is the lower one. And in the first quadrant, all are positive. Add sugar to coffee. Second and third quadrant, cos is negative. Fourth quadrant, it is going to be positive again. Alright. So cos x will always be greater than or equal to half from here, from the diagram. So cos x will always be greater than or equal to half if you deal with minus pi by 3 to pi by 3 interval. What do you have f dash x? Cos x minus half, which we already differentiated. Now it is saying that cos x is greater than or equal to half. This cos x will always be greater than half. Again the same concept. If you take the minimum value of cos x, it is negative 1. What is the highest value of cos x? It is positive 1. So you put negative value, you put positive value and see what do we get. Okay, cos x is greater than half, and once we have cos x which is greater than or equal to half and you subtract half from it, you will always get a positive number. I am saying x minus y. X is always greater than half. Say x is always greater than y. So you will always get value which is greater than positive, which will be positive, or the least possibility is 0. So it will always be positive. So f dash x will always be greater than or equal to 0, which means this function is increasing in this negative pi by 3 and pi by 3 interval. So this diagram is very important. The concept of trigonometry is very important. So this is the simple explanation and reference for you. If the function f(x) equals to this one is increasing on R. Now increasing. First let us differentiate it. The best thing is the differentiation in increasing and decreasing function. We'll differentiate it. X cube is going to be 3x square minus 18kx plus 27. So this is 3 being common. We have taken 3 outside. It's x square minus 6kx plus 9. Okay, f dash x is greater than, it is increasing, so it is greater than 0. So 3 is positive, so we don't deal with 3 now. We have to deal with x square minus 6x plus 9 greater than 0. And you already know that when we have nothing in our hand, if an ax square plus bx plus c, which is the quadratic equation which is greater than 0, what do we get? When a is greater than 0 and when b square minus 4ac, which is the determinant, is less than 0. Now when you compare this x square minus 6kx plus 9 with the ax square plus bx plus c, a is 1, already it is greater than 0, 1 is greater than 0. So only thing which is left with us is b square minus 4ac should be less than 0. What is b? Minus 6k. What is a? 1. What is c? 9. So you have b square minus 4ac should be less than 0. So this is 36k square minus 36 less than 0. I am taking 36 common. We will divide both sides by 36. So you'll get k square minus 1 less than 0. 36 you can just divide. So k square minus 1 is less than 0. So when you have k square minus 1 square less than 0, it is k minus 1 into k plus 1 is less than 0. And when you have two factors multiplied and when we have less than 0, what do you do? I already told you in the beginning of this chapter. When k minus 1 will be 0, when k is equal to 1. When k plus 1 is 0, k is equal to minus 1. So you have minus 1 and 1 here, and you have to take the values which is, because it is less than 0. Greater than 0 will give you something else. Less than 0 will give you something else. That is, it has to be between a negative 1 and 1. You can write k between negative 1 and 1. What does that mean? See, the options are not there. The first option is the correct answer, but it should not be less than or equal to. That is, the correct option should be k between negative 1 and 1. That is going to be your answer. So there is some point here, and let me give you a disclaimer also, which you see on the right bottom. There is some catch here, but first is the option. Now this is very straightforward question, this one. Just differentiate it. F dash x directly we'll find out. It will be 9x to the power 8 plus, I'm just differentiating it, plus 21x to the power 6. The 64 will be 0. So f dash x, you don't have to worry about anything. Everyone has the power which is even. X to the power even will always be positive. So 9 into positive plus 21 into positive, this f dash x will always be positive. And when you have a positive value, whatever you give x, it will always be positive. So x can take any value from any number existing, and any number existing is nothing but the real number. It's R. Alright, the answer is real number, you give any number, it will always be real number. So I'm making the real number here, number line here, minus infinite to infinite, any value you can take, and this negative infinity to infinity is pertaining to the r, which is the real number. This is the reference for you. This is all about this chapter. Thank you so much. Take care of yourself.